Hi, Dr. Schrage here, and I will have a little demonstration to show you with regard to how dew point temperature works. A lot of students get confused about how can a temperature possibly measure the humidity of the air, and I want to show you, and it's actually something that you've seen 100 times in your life. Notice how sometimes when you have out a beverage, such as this can of Coke, you get a puddle of water on the ground, there's all this condensation. On the other hand, sometimes you have out a container of a liquid, such as this bowl of water, and there's no condensation at all. Well, this has to do with the temperature of the container and how it relates to the dew point temperature. At the present time, I have some water in this bowl, and the temperature of the water is about 26 degrees Celsius. That's about 78 degrees Fahrenheit. 78 degrees Fahrenheit is higher than the dew point temperature in this room. And the way I know that is because if it were lower than the dew point temperature in this room, dew would begin to form on this bowl. This Pepsi just came out of the refrigerator. It's much colder than the dew point temperature of the room, and it's making a big puddle on the table. We can actually estimate the dew point temperature of the room by cooling down this bowl until dew begins to form on the outside of the bowl, at which point we apparently are at the dew point temperature. So I'm going to take some ice from this bowl and put it into this water. So this water starts to cool down, and as the water cools down, presumably so does the bowl itself. And what we're going to do is we're going to watch as the temperature falls, and we're going to see if at what temperature condensation begins to form on the outside of the bowl. Now, if you paid attention in lecture, you know condensation is actually happening all the time on the edge of this bowl. Whether or not condensation accumulates is a different story. It's all about the balance between condensation and evaporation. What controls the amount of condensation going on? Only the humidity in the air. The higher the humidity, the more condensation is happening. But we're not actually changing the humidity in this room at all. On the other hand, what controls the amount of evaporation going on is just the temperature of the air. That's the Clausius-Clapeyron equation. Well, we are changing the temperature of the air that's touching the edge of the bowl. We're reducing the temperature, so we're reducing the evaporation rate. The same amount of condensation is happening all the time, but we're reducing the amount of evaporation. And as the temperature of the bowl falls, at some point we will start getting the evaporation rate to be less than the condensation rate, and condensation will begin to accumulate on the edge of the bowl. I think we're almost there. A little spoon here to stir this a little bit. Help the ice cubes melt a little. Okay. The edge of the bowl is just starting to get moist as dew begins to form. We haven't changed the condensation rate. Exactly as much water vapor is condensing on the edge of the bowl as always was. Well, we've changed the evaporation rate by cooling the bowl down. And this happened at about 10 degrees Celsius. That's about 50 degrees Fahrenheit. So we would say that the dew point temperature in this room is 50 degrees Fahrenheit. We had to cool the air to about 50 degrees Fahrenheit before the condensation rate was greater than the evaporation rate. Technically, actually, that's when it became equal to the evaporation rate. And condensation began to accumulate. Now, in this example, we cooled the air down around the bowl. We reduced the evaporation rate in order to get condensation. Another example in your day-to-day life, though, involves adding moisture to the air, and that's the shower. When you're in the shower, the mirror tends to fog up. You haven't changed the temperature in the room all that much. In fact, if anything, you've made the room warmer when you took your shower, which should have increased the evaporation rate. It made it less likely for condensation to accumulate. But you have added lots of moisture to the air. You have increased the dew point temperature. At some points, the dew point temperature in the room was equal to the air temperature. Condensation rate got faster and faster because we were adding more and more moisture to the air, but nothing was changing as far as the evaporation rate goes, and so condensation began to accumulate on the mirror. So anytime the temperature of some surface is less than the dew point temperature at that time, condensation will begin to form. Now here's something to wrap your head around. Let's say it was so humid that the dew point temperature of the air was 98.6 degrees Fahrenheit. What surface has a temperature of 98.6 degrees Celsius, 98.6 degrees Fahrenheit, so that condensation would be forming on it? How about the interior of your lungs? Yes, if it was ever so humid that the dew point temperature was actually 98.6 degrees Fahrenheit or higher, dew would form in your lungs and you would choke on the air. How cool is that?
Vader, the fleet has moved up flight speed and we're preparing to...
You have failed me for the last time, Admiral. Captain Piet.
Yes, my lord.
Make ready to land our troops beyond their energy field, then deploy the fleet so that nothing gets off the system. You are in command now, Admiral Piet.
Thank you, Lord Vader.
So maybe the dark side of the Force is nothing more than a really firm grasp of the concepts of moist air thermodynamics.
Dark side of the Force is a pathway to many abilities some consider to be unnatural.
Is it possible to learn this power?
Not from a Jedi.
No, but you can learn it from Dr. Schrage. This has been Understanding the Dew Point Temperature by Dr. Jon Schrage, copyright 2005.